Hi, good afternoon, everyone, and welcome to our webinar series RE Tech Talks. This webinar is being organized as part of the collaboration between BEEP RE, a project on integration of renewable energy in buildings implemented by IIEC and supported by Swiss Agency for Development Cooperation (SDC) and U Solar Clean Energy Solutions. My name is Anand Joshi, and I am excited to be your host today. In this series, starting today, we will be exploring a variety of topics related to implementation of renewable energy projects in buildings with our expert speakers. Please mark your calendars for these webinars, and we also be sending out the reminders and updates to all the attendees. In this webinar series, our aim is to provide you with valuable insights and information on RE technology and their implementation from our highly experienced speakers who are passionate about sharing their knowledge with you. Before I invite our speakers, I would like to run you through the GoToWebinar interface that we are using for this webinar. For the entire duration of the webinar, your microphone will be on mute and webcams will be turned off by default to avoid any accidental background disturbances. During the webinar, if you have any questions, questions and handouts, questions and chat options available in the webinar platform on your right side, and we will take the questions whenever we have them. Also, we have shared some handouts with you. You can use these handouts to refer any additional information. Please note that this webinar will be recorded and the recordings will be made in public domain. Thank you for your patience. And without holding you any further, I would like to invite our first speaker, Mr. Sanjay Dubey, President and CEO of International Institute of Energy Conservation, for sharing the opening remarks. During the webinar, Dubey has over 32 years of experience, and his dynamic portfolio consists of working on clean energy and climate change related programs. He has worked on the multiple projects supported by different international agencies. Sir, the mic is yours.
Thanks, Anand. I hope I'm audible. I'm really excited to note that U Solar and IIC's and SDC's BEEP RE project is organizing this series, and I think this is going to be really useful of sort of sharing the real work that the programs are doing and the private sector is doing in the market, and that is something useful for taking this forward for real implementation in upcoming projects in India, which we really need. The BEEP RE project initiated like 3-4 years back, and the entire objective, to look into the building sector where how the renewable energy technologies can be integrated. It's not that the renewable energy technologies are not being utilized in buildings. There's a lot happening in India and around the world. But for this specific program, we had a different objective that when exactly the decision is being taken for selection of a particular technology or integrating the kind of technology for using renewable, the percentage of renewable energy in buildings. And that is the most important aspect that has been kept in mind while designing this project. So from the conceptualization of building design stage and then the design stage, one should consider that do the feasibility and see that in which area the building is falling in, and then what kind of technology or the hybrid technologies or the combination of technologies can be deployed. So that we can come up with different examples. Those can be replicated around the world, and especially different climatic zones in India. So with that, great objective in mind, the entire project was conceptualized, and we also decided to document each and every step of the project. How the buildings are selected, how the technology is being decided, what kind of technologies those could be feasible for a market like India in different 6, 7 climatic zone that we have. And also then, once the technology list is ready, then how the feasibility should be done for a particular climatic zone for using that technology. And if that is not sufficient, that, how other combinations can be, basically devised. And if somebody wants to go net zero, then, what is the process to procure green energy, or, uh, from various sources. So this is how the entire process continued, and then we basically are coming up with a guidebook and also technical specifications for sharing with the market. Uh, During the entire process, it was also decided that we should do some pilot. That Sonia ji will share the project details with you after me. But then I'm trying to set the context here, that how important this program is, and how important is our partnership with private sector. And U Solar is one of the leading partners there, who basically are going to come up with different solutions. For they are already doing good work, but we will come up together with different solutions for the market. So, all your opinions and suggestions, or questions are very valuable for us. Whatever you feel like, please feel free to ask, put your questions in the chat box. We'll respond back, and we'll be happy to share information. And project is also coming up with a website there, where most of the information, mainly the technical and process information, will be available. So here I am, and I would like, basically, I hope that you will enjoy the discussion today, and many more to come as a series in future. So thank you very much for being here, and looking forward to interacting with you all. Thanks.
Thank you, sir. Now, I would like to invite Ms. Sonia Shukla, Senior Project Manager, IIEC, to present about the renewable energy technologies. Sonia has over 12 years of experience, and she's working on energy efficiency, electric vehicles, clean energy, access, sustainable development, and sustainable financing programs of IIC India, and she is leading the multiple teams of IIC India. Over to you, Sonia.
Thank you, Anand. I hope I'm audible. Okay, so good afternoon, everyone. Thank you for taking out time to listen to us. As Anand said, I am Sonia Shukla, the Senior Project Manager at International Institute for Energy Conservation, and I'm going to talk about the role of renewable energy and the technology options for building integration. So just a brief overview about IIEC. International Institute for Energy Conservation is a Section 25 company registered in India. We have offices in US, Thailand, and Philippines, and we have primarily been incorporated to fulfill the objective of helping the economies in transition and developing countries to work around the major sectors of energy efficiency, clean energy, and energy conservation. Currently, IIC is now more than 35, 36 years old, and we've been majorly working on areas of energy efficiency, standards and labeling, renewable energy, building integrations now, transport and clean transport advisory, climate change, water resource management, and other sustainable development areas. Okay, so to talk about this work, the project that we are doing with the Swiss Development Agency, the project was conceived around almost 4 years ago, and it had a bold outcome of identifying and integrating renewable energy technologies in buildings. Okay, and intention was also to identify the monitoring methods, performance measurement techniques and tools, and also to do a capacity building and knowledge sharing exercise based on the work that has been generated by the project. So project has actually worked and achieved substantial results. We have been able to do a rigorous market assessment to identify list of renewable energy technologies which are very suitable for building integration. We have done and developed several tools and templates and fact sheets around these RE technologies on how to do the assessments and what are the basic design considerations that should be kept in mind while thinking and assessing any specific technology. A very important step in the project was collaboration and engagement with both private and public sector. And this was also to do and identify possible sites and projects where the renewable energy technologies that have been identified can be demonstrated. So right now we are working with two private sector and one public sector project on actual integration of these RE technologies. We'll discuss that in a bit. And these demonstration pilots actually helped us in understanding the entire process of renewable energy integration, on how is the capacity assessment and resource assessment done, and to the end process of actual procurement and installation of these technologies. A very important element of the project was or is capacity building and knowledge sharing. And for this, we have been sharing the knowledge and the documents and the tools, templates, guidebooks developed under the project through our website and Veep page also, which and some handouts are available here as well. And these would be available on the Veep RE web page also, that we will share. And this capacity building exercise has now extended to actual handholding of the architectural schools, so that the education is imparted right at the education or at the study level, so that when these people have become architects or designers, they know where to start, what to look for, and how to go about the process. So we have fostered collaborations with the School of Planning and Architecture, Manipal universities, and similar other institutes, wherein we are helping them design and update their curriculum to integrate information about renewable energy technology integration, because that is the basic step that we've observed and found is required when we design or when we look for a green building design. Okay, so before diving deep into the subject, I would just like to briefly touch upon why should we look at renewable energy technologies for building integration, and what is the role that they can play for us. So as we already know that buildings are second highest consumers of energy, and therefore reducing this energy consumption makes a lot of sense for both energy security as well as environmental security point of view. And therefore renewable energy and energy efficiency are two key stepping stone on which this overall energy consumption can be reduced. So therefore we have kind of summarized the entire approach into these 4 steps, wherein you see that passive design features incorporation, orienting the building, incorporating the elements of natural ventilation is the prime and foremost step for doing right building design. The second step is actually using low energy building materials to reduce the overall consumption from the life cycle of the building. Third comes the energy efficiency and demand reduction strategies, wherein through which you can actually reduce the overall demand for the energy requirement from the building. And the last step is the integrating renewable energy. So if even if we are talking about renewable energy here in this discussion, but for the sustainable design of the building, renewable energy actually comes at a very later stage once we have incorporated all the possible elements that can reduce the energy and demand for that building. So once we understand that this is the process of going about designing a sustainable and green building, and now let's talk about what are the technologies which are suitable for renewable energy point of view. So we already know that solar rooftop is a very prominent and promising technology. It has been used, utilized, and it is well known for the designers, architects, building owners, everybody. We've been seeing rooftop installations all across the country, and it is actually a very useful option for designing sustainable buildings. The second comes is the building integrated PV solutions. We'll discuss each of these technologies subsequently in coming slides. The hybrid solar PV and hybrid solar technology is a very interesting technology wherein you combine the electricity generation and hot water generation features together into one single installation. Then small wind turbines are actually a very potentially useful solution, and several innovations and designs have now come up which are available in the market as well. And when we create a hybrid project in combining this solar and wind, we get a very optimum energy production solution. But then next is the biomethanation or biomass energy generation technology, wherein the organic waste from the kitchens or from the premises of the building can be utilized for generation of biogas. This is again not a new technology, but has been innovated, and now several tech-based solutions are also available for biomethanations. Battery storage again is an excellent option for storing and consuming the power later, specifically in off-grid solutions, off-grid options. And since the costs of batteries have also come down to some extent, this is a very sustainable solution, I would say, for off-grid systems. Then fuel cell is these are last two are very not new but upcoming solutions, wherein if we can integrate it with the renewable energy options, then it becomes an excellent energy efficient and renewable energy solution for driving the energy consumption of the building. Let's look at each of these technology, at least an overview of these technologies. So these are the technologies actually that we are going to talk about in detail in this entire talk series. And we would look at what is this technology about, what is the working principle, how does it operate, what are the major business models, what are the financials, how to do the how to assess and do a capacity assessment or sizing of each of these technologies. So we will be dedicating each webinar for each of this technology in the coming webinar series. So let's have an overview of each of this technology in a very, I would say, concise manner, so that we at least understand what we are going to look at in the coming webinar series. So I don't need to actually explain solar photovoltaic. I think it is something which is very well known. Voltaics are actually not a very new technology, but there's still a lot of innovation going on for having flexible solar panels, having installations which can be integrated at any surface, at any level, and the efficiencies can be improved. Because the only concern that we have with solar is the efficiency, because efficiencies are still low. And then there are multiple kind of business models, options available for consumer to choose from, and we have numerous technology providers, system integrators in the market, in the country, who are providing these kind of solutions. And this is a very default solution in designing a RE integrated building for getting your green credit ratings also. So this is something which is very popular, very well known, and with falling cost of the technology, it has become extremely cost viable. It is even in for the buildings, the cost of installation and cost of generation of electricity from solar is much less than cost from generation from the grid. This technology is a no-brainer for any developer and building owner, and for reduction and utilization of whatever benefits and incentives are available for RE technologies. This is a go-to technology for everybody. So in offshoot of solar PV, I would say is building integrated PV solution, wherein you integrate the solar panels on the facade of the building, so that you are able to generate electricity not only from the roof but also from the sides and walls, front walls of the building. Now then, integration of BIPV, there are multiple design considerations that we need to take into account, and this again goes without saying that orientation and facing of the building becomes a very important aspect when we do building integrated PV solutions. So there are the components are similar to the solar rooftop system. Just the panels are integrated on the front wall or wherever we get the maximum sunlight on the part of the building. And BIPV is still, I would say, not a very commonly used technology, although it is very promising. But the concern is as the orientation and all those considerations need to be taken into account, the efficiency of the generation from BIPV is extremely low if we compare it to the rooftop solutions, and therefore the costs are associated are also high. So this makes sense for properly designed building, wherein you get good amount of sunlight in the wall, wherein the panels are integrated. And again, there are some specific elements that needs to be taken care of when we are thinking of BIPV. So this is a classic case wherein technology integration as a retrofit doesn't work quite well. So these kind of options and solution need to be integrated at the design stage of the building, so that you get a maximum output, maximum efficiency at a optimized cost. So these are some basic consideration design elements that we need to consider, that buildings which are in a dry, dusty environment, they will require a lot of cleaning of the panels, frequent cleaning of the panels to reduce the efficiency losses. And if BIPV is being integrated as a daylighting as well as electricity generating solution, then it becomes a less costlier option, I would say, because that is why you need to integrate it at the design level itself, so that when we are constructing the facade, so instead of having the glass and putting the roof solar panel on top of that glass, combined transparent glass, so we need a different kind of panel also again for BIPV, and then that can be integrated at the construction stage itself, so that at least the cost on parts of the materials and the labor are optimized. Then ventilation, local climate, and potential shading are few other things that needs to be kept in mind at the time of designing a BIPV solution. So next is hybrid solar photovoltaic. So this is a very interesting technology wherein photovoltaic panels which convert solar radiation into electrical energy are combined with the thermal collectors, and so whatever I would say the energy is hitting the top surface of the panel gets converted into electricity through the photovoltaics, and then the remaining amount of energy what is captured by the thermal collector at the back of the panel, and the waste heat is absorbed by those collectors. So this helps in improving the overall efficiency of the system, and this system is very suitable for the places where hot water demand and electricity demand is required in combination. Say for example, in hotels or hospitals or maybe residential systems. So this technology makes a lot of sense there. Although there are not a lot of providers for photovoltaic, sorry, hybrid photovoltaics, but the number is growing, and there are a few which are available in the country. Next technology is the small wind turbines, building integrated wind turbines. There are multiple options. This is again a very old technology which has been innovated, designed and experimented with. And for building designs and building optimization, we have now several models which are available. There are multiple players also which are available and who provide turbines which are a good solution in terms of both electricity generation, lower noise levels, environmental friendly. So all these considerations and limitations of the large wind turbine technology have now been more or less been taken care of now. The next is biomass energy. Biomass energy is actually nothing but conversion of organic biomass into biogas or electric power through anaerobic digestion, wherein this biogas which is generated is excellent quality biogas, and it can be used for replacing the LPG directly in the kitchen with some amount of filtrations and clarifications. But this is a very, I would say it's a dual solution for both waste management and disposal of organic waste solution. Therefore, okay, so this is a dual solution, or it tackles the dual waste management as well as providing a cheaper means of fuel which is used in the kitchen. This is a or corporate parks which have huge kitchens, and the organic waste must be digested and fed back to the kitchens in form of biogas for replacing the LPG. We have looked at least the basic features of each of the technologies. So there are, if we look at it for a building premises, there are majorly three types of resources which are available: wind, solar, and biomass. And these are the three resources which are utilized in various forms for providing the end use energy requirement for any specific building. Understanding what each technology, it is very important to identify which technology would be suitable for my particular building or my particular place. So we have devised this very simplistic process, and we have used this for our pilot projects also, which involves basically 4-step involves. First is the basic data collection from the site, identifying what is the consumption, what is the type of load which are going to be there, what type of electricity consumer or energy consumer the building would be, and what are the applicable tariffs, both electricity and thermal energy. Then identification of the resources, RE resources which are available at the site. Say for example, is solar available, is wind available, whether there would be enough waste for conversion to biogas. So all of these three options needs to be studied and identified. And then the say for example, if you're designing a building in northern part of India. So most of the landlocked parts generally do not have much of wind associated. Therefore, then each of these resources which have been identified need to be assessed. So we need to understand and assess what amount of space is available if we are going to install solar. If there is an adequate amount of solar available based on the capacity assessment studies, resource assessment studies, then we can look at solar as an option. Then also looking whether end use requirement also needs hot water. So then we can combine solar water and the photovoltaic panels together and use the technology, the hybrid technology. So these are this is the step on how do we decide and how do we do a assessment for each of these technology option. For wind, we study the windrows diagram of that particular area and identify whether the wind would be a suitable resource for this particular building or not. And then third, what is the expected amount of biomass generation, organic waste generation at the site, and whether that would be feasible enough for installation of a biomethanation system. Once we have identified shortlisted, so for this particular step wherein we need to do the capacity assessment, resource assessment, we have developed a very simple RE assessment tool wherein you can feed the data of the climate of that particular location and the end use energy requirements, the expected loads, etc., and the space availability, expected waste of generation, and then the tool calculates and gives you feasible technologies that can be integrated at that site. So that tool is available with us, and I think a digital version is also being created, and it would be soon be available for public use. Then after doing this entire assessment, the next steps become, say for example, we've identified that solar and biomethanation are two potential technologies that would be very useful for my site. I am designing a hotel and will have a huge roof space, some space on the ground as well, and would have a huge kitchen, will be generating a good amount of, say for example, 1 tons of waste per day. So then identifying these technologies, doing a basic financial calculations of these technologies, and assessing the overall viability of these technologies, I shortlist these two, solar and biomethanation, as the potential technologies for installation. Now what? Then I need to do a identification of the vendor, the technology provider, who will provide the technology, what are the system integrators available in the market, who is offering what solution, what kind of business models are available. So that becomes the third step. Identifying the vendors and developing the technical specifications for the particular technologies that we are envisaging for installation. And after we have identified the technical specification, design, the tender documents, etc., we invite proposals. That's a very standard process in any company or corporate, and then those the proposals are finalized, vendors are assessed, etc., and then final decision is whether the how would the solutions be financed, whether it would be done through own equity, through loan capital, through crowdfunding. All those options and information can be identified, and basically solutions can be proposed. If we want loan, then the entire DPR proposals, etc., will be created and given to the bank for approval of the loan. If this is equity, then the entire financial calculations, parameters, etc., assessment will be done based on the quotations and technical specifications given by the final technology provider. So then this after we have done this, the process of procurement of the technology, installation, monitoring, and commissioning happens. And this is how the overall process of RE technology integration takes place. Here, one point to note is that we have, if it is kind of evident that we have considered that all this process is happening, at the foundation level, when the building foundation is being laid, when the building is being designed, it's in the planning stage, then and at that time itself we need to do this entire process, because optimization of the building design and the structural elements of the building become very important based on what technology we are going to install. Say for example, if you are going to if we find that small wind is also feasible, and we are interested in doing small wind turbines, then having the right kind of structural strength on the terrace and rooftop is important. So at this stage, all the design teams, the working teams of the entire mm, builders and real estate developer need to sit together, brainstorm, and finalize the specifications of the buildings as well. If it is not done at this stage, then installation of a lot of technology becomes very limited. Case in example is, we were working with a developer, and they had asked us to do this process for one of their sites in Bangalore. Now the designs were kind of frozen, and it were given to us for assessment and identification of the technology options for integration. So we looked at it, and we found that a lot of aesthetical elements were built into the design, which were kind of shading the entire roof space which was available. And since the design was approved, it was already given and forwarded to the marketing. There was not a lot that we could do, so all those design elements restricted the amount of solar rooftop that could be installed on the building. So it becomes very important, therefore, to sit together at the planning stage itself, while the building is being designed, to look at all these technology and RE integration. In fact, even the energy efficiency integration needs to happen at the design stage itself. Retrofitting is a very limited option. Probably a few solar rooftop solutions could be feasible, but rest of them, or maybe biomethanation, but rest of them requires a lot of planning at the beginning itself for integration. Yeah, so this is again the same thing, describing the second step in detail on how the site resource assessment is done. For solar, we do the sun path analysis, shadow analysis, weather data understanding, looking at the wind flow and windrows diagrams, identification of the solid waste amount which would be generated, and then taking all these variables and parameters into account, calculating the overall potential for each technology that we have identified or shortlisted. Then the second step comes of the actual technology evaluation. What brand, what design, what kind of rating of that system needs to be provided or cited, so that you get a best performance as well as a best kind of cost estimates as well. Then the final step in the RE technology assessment is the cost benefit analysis, financial analysis, wherein we identify whether the technology would be commercially viable for that particular site or case also. Yeah, so this is how we did solar resource assessment and wind resource assessment for a particular site. And we found that both solar and wind are potentially applicable solution, and both were suggested and integrated in the building design. Yeah, that's it from my side. I would be happy to answer questions that you would have, and thank you for your patience and for joining us today. Thank you so much.
Thank you, Sonia. Now, I would like to invite Ms. Dhwani Sanku. Dhwani is a highly motivated professional, and she has an experience in implementation and design of renewable energy projects. She's extensively working for solar energy and BIPV installations at U Solar Clean Energy, and she heads the business development department. Over to you, Dhwani. I'll share the presentation and give you the controls.
So good afternoon, everyone. I work at U Solar. This presentation is designed to detail the renewable energy system deployment process, specifically with respect to solar integration technologies. So I'll just walk you through the agenda and then I'll jump into the flow of the presentation. I will be introducing Youth Solar, the company, and what we do. That will lay a foundation of our expertise. Then I will dive into what the solar integration types are. A lot of this has already been covered by Sonia in really good detail. So we can understand the solar deployment process from a commercial perspective and how we put together solutions and take it to market. The factors that will be considered in rooftop solar and the factors that are considered in a BIPV system. And then we will touch upon the economic considerations briefly. As you are aware, the BEEP webinar is a series of talks, so we will be diving into each of these processes in detail over the course of the coming weeks. So we at Youth Solar, we're a pioneering solar energy company. We have integrated solutions across different technologies. We've installed 250 plus kilowatt peak solar projects over the span of 12 years. This cumulates our capacity of installations to 170 megawatt peak. We're looking at increasing this capacity by the end of this financial year over 250 megawatt peak. We have pan-India reach, so we are able to install projects everywhere in the country. We're in the process of our international expansion as well. We're able to provide end-to-end solutions. So from the conception stage all the way to the commissioning stage, we do everything in-house. So our expertise is design and engineering. The modus operandi is project development. So we do CapEx, OpEx, and group captive. These are different financing mechanisms for solar PV systems. We also do EPC construction for larger assets, and we manage our assets that are developed under the OpEx model through our asset management service, which is also offered to the market for O&M contracts. A couple of services that we are able to provide include rooftop solar, ground-mounted solar, BIPV solutions, battery storage solutions, as well as carport systems. So today, if a company is, consuming a large quantum of energy, obviously their operations will be increasing year on year as a corporate grows. It's absolutely a no-brainer to install solar. Through this presentation, I will walk you through why, and at the end of it, I believe you will be convinced on why solar needs to be a decision for every single facility, every building at the integration and design stage. So rooftop solar can be installed in commercial facilities. It can be installed in homes, apartment complexes for the common loads, at even industries. So you can see here in our picture there are 3 different types of solutions. Each of them are a different composition of a rooftop system. One of them on the top left is PV modules installed on shingles on the roof. Another one on the top right is PV modules installed in a high-rise structure on top of a residential house. Both of these being residential are quite different in their engineering aspect. And at the bottom, you can see that is a rooftop installation on a sheet roof for a large industry, or it could be a warehouse as well. Then moving to ground-mounted system, this is very popular. Most of the solar projects are advertised as ground-mounted systems, so we won't get into it in detail. But I want to highlight specifically the difference between a rooftop and a BIPV system. This is very important to understand when choosing your integration technology. As you can see in this picture, the one on the top is similar to a couple of the pictures we saw previously. So rooftop system is integrated to an already pre-existing roof. So it's more of a retrofit mechanism on a roof that is constructed. This can be done, if feasible, at any lifetime of the building. Whereas a BIPV system is balcony type, curtain wall type, sunshade type, and wall type. All of these are integrated into the architecture of the system, and they replace an integral element. So not only will they have the function of energy generation, but they also have to serve the function of the material that they replace. Sonia did explain in the previous section that this could be ventilation, it could be light, it could be insulation for the building, so on and so forth. Again, I'm going to skip solar and storage systems because it is a solar system with a battery addition. This could be lithium ion or lead acid. Moving to carport systems, these are superstructures that are built to provide shade for the carport. Instead of creating shade roofs, we will integrate solar PV, so it will have a dual purpose. Not only will it provide shade for the cars within the car park, but it will be an energy generation source for the facility. The financial models that are most popular for the adoption of solar are the CapEx and OpEx model. It is pretty self-explanatory. In a CapEx model, you create an upfront investment. Operations and maintenance needs to be paid. As I mentioned earlier, asset management services offers this to our clients. Ownership of the asset lies with the purchaser, and the return of investment is within 4 to 6 years. Whereas within the OpEx model, it is a zero investment model. A developer such as Solar would come in and create the asset and then sell the power to the consumer at a LCOE that is lower than the electricity bill. There are stringent qualification criteria for the OpEx model since it is the developer's complete investment. Most of this criteria relies on the balance sheet of the consumer. And the ownership of the asset will remain with the developer for the duration of the power purchase agreement and automatically transfer at the end of the duration. So let's dive into the solar system deployment process and understand what are the steps required to purchase a solar power plant. So the first step is to do an initial assessment. This would include an estimation of the capacity, the estimation of the price, and the overall feasibility of the project. In order to do this, we ask our clients to send us their rooftop diagrams, either in AutoCAD format, or we ask them to send us a Google coordinate so that we can tap into our resources and do our assessment through satellite imaging. We also ask for electricity bills for 6 months. The ideal would obviously be a 12-month period, which would give us an entire understanding of their energy consumption pattern through the year. Once we have understood their energy consumption pattern, we size the solar plant. We will have to do a site survey to understand if there are any obstructions that are not visible through our imaging softwares, do a roof assessment to check the load bearing capacity, and also figure in the termination details of the plant. Once all of this information is put together, we have completed, in essence, our technical evaluation, and we have the ability to create a bill of material and put together a commercial offer. So a submitted, design brief with the estimation on the cost, the layout, the savings, the returns, the financial outlay is provided to the client. Once this is accepted by the client, generally after a couple of rounds of negotiation, a project is commissioned. So the commissioning of the project in itself is quite an elaborate process, which we will get into through the series of these events. Yeah. So our first step being the solar assessment process, we have to take three key considerations. One is the energy consumption. The second is the solar state policy. And the third is the space availability for solar. All of these are done in unison for us to understand what the capacity would be of the solar plant. We have to obviously follow the regulation, and we have to give our client a solution that is mutually beneficial. In case we size the system too large, then they are investing in something that they might not consume. In case we size the system too small, they are still not maximizing on their saving. So it's very important to understand their consumption. We'll get into each of this now, starting with the availability of space. It's a crucial decider in selection of the integration type. So whether we go for rooftop, whether we go for ground mount, whether it is a solar plus storage system, carport, or BIPV, we have to understand what is the space available in that facility. So obviously the first step is to understand the energy consumption. Once we know that, we have a rough idea of say how much solar is required by this consumer, and then we look into how much area is available. So some of the thumb rules we use to assign these information is 1 kilowatt peak of solar generates 1350 to 1400 units per year, and 1 kilowatt peak of solar requires 10 square meter to, or 1000 square feet of space. So then we will look into, okay, is the rooftop large enough? Does the rooftop have enough space? Let's take an example. If the consumption of the client is, let's say, 50 kilowatt peak, and their rooftop space is only 40 square meter, 400 square meter, then we're only able to install 40 kilowatt peak at their asset. So that's not large enough. Do they have available ground space? Some very large industrial facilities have additional space, behind the factory or ahead of the factory. They can install the additional rooftop solar there. If some of these very huge warehouses, and shopping centers will have very large car parks, such as arenas. So those can be converted into solar carports. Airport, for example, have very, very large car parks. And our last step is to understand the diesel generator consumption. How long is the diesel generator run for? If it is extremely long, then we can supplement the solar power plant with some storage. Storage and solar in itself is not yet commercially viable because the cost of lithium right now is very high. As that comes down, we will be able to integrate storage into every single rooftop or ground mount system to improve the yield. Now, understanding energy consumption patterns is important because each facility will require different, I would say, different quantums of energy at different periods of time. For example, a warehouse will be using very low quantum of energy, but they will use it throughout the 24/7 period. But a factory will have high energy needs during certain times of day. A mall or data center will have very high consumption through the week, and a data center will have very high consumption through the week, and a mall might have very low consumption through the week and very high during the weekend. So this is why we get into a couple of months of energy consumption patterns, so we are able to draw out what the actual requirement is. So electricity bills for the past year is a great idea to understand the base load, and we try to map the energy requirement based on this information that is provided to us. A lot of industries also look into how many holidays they have, how many maintenance days that are considered for their consumption patterns, so that their losses are not too high. Another very important consideration, especially when we are talking about the Indian market, is the solar state policy. Each state has its own policy, and these policies sometimes vary considerably across states. What we need to understand is the implication of net metering. Net metering is the export of excess solar energy during non-consumption days. I already touched upon holidays and maintenance days, for example. Let's say for a university that wants to install solar power plant, what are they going to do during the summer vacation or the Christmas vacation? Solar is still going to be generated, but they will not be consuming a lot of it. So their investment should not be idle. The mechanism of net metering allows them to export this energy and net it off in their next month's bill. So a couple of things that vary across the states are the net metering export tariff. It varies state to state. It's typically between 2 to 3 rupees. There are also considerations such as the contract demand, which is your metering load connection that is taken when you ask for a grid connectivity. So the amount of solar that is possible depends on the connected load or contract demand. So in Gujarat, for example, it's 50%, in Karnataka it's 85%, in Andhra Pradesh it's 100%. This changes from state to state, and the policies also continually change. So we have to be very aware about what's happening from a policy perspective and map this while designing the solar asset. So we'll touch upon a couple of factors that need to be considered while curating the design of a rooftop solar plant. So the first point is the type of roof. There are different types of roofs. As we all know, they could be dome shaped, they could be flat, they could be, pyramid shaped, so on. So we have to understand what is the type of roof, what is the material that is used to construct that roof. Does that material have a load bearing capacity of the solar plant that we plan to install on top of it? What is the structure strength? And of course, are there any obstacles that create shadows on the roof? These considerations are important on panel placement and the orientation of the panel. We also look into, if there are any hotspots in the modules, hotspots due to shadows in the modules. If there are many moving shadows, the voltage changes through the day will create damages in the modules. We also have to ensure that optimal angle of tint and orientations are maintained. So sometimes we are restricted on how many improvements we can add to a rooftop solar system because we are restricted by the fixed orientation of the roof itself because of the building. It might not be true south, it might be north oriented. So automatically a rooftop solar on that roof will have a lower yield as compared to another one. So rooftop solar is in a sense a very highly customized solution. And the last point is we have to look into the availability of reliable grid infrastructure. The startup power for any rooftop solar plant is provided typically by the connection to the grid, even if it is not using a net meter system. There are also some other considerations that can be taken if there is no strong grid connectivity. We will then install a hybrid system or a off-grid system. A hybrid system could be connected to a DG source or a battery, and a hybrid system, an off-grid system is connected only to a DG source. So I've gone through a couple of considerations, broad considerations on the type of roofing material. So a couple of examples that we have to look at is for a sheet roof, the galvaninium sheet needs to be greater than 0.47 mm. Asbestos sheet is absolutely not recommended. We usually ask our clients to change their sheets if it is asbestos to something more reliable. They need to have load bearing capacity. Most roofs already do because per square meter a solar plant uses 15 kg, so it's not that much. But we will still look into the load bearing capacity. We do a load flow study, a load analysis using our softwares such as STAD Pro and so on. We also look at safety, since a lot of these rooftops are a couple of stories high, we have to check if there are railings, fall protection, if there is safe access to the roof. A lot of material movement will be happening during the installation time and also during the maintenance process post installation. So we look into these. All of our solar assets follow very high safety norms. And as I discussed, orientation is a key factor. While we have restrictions on the orientation, we do try to optimize a lot of our solar at the south-facing roofs, and then look at the other faces if we need to maximize the generation. East and west works well in many places. India has the benefit of having a high yield in general, but north slope we try to avoid. The solar panels are integrated to each roof in a different mechanism. An example over here is a sheet roof system. We use clamps that are placed on the panels between the sheet roof and the PV structure, and the structures are laid down on the clamps and the PV on top of the structure. We also have to take into consideration skylights and ventilators, not only during the installation process, but as I mentioned previously, we will have engineers visiting the solar plant and the roof frequently during the lifetime of the project. Another way to utilize it is by picking roofs that have some kind of pre-existing tilt, so that improves automatically the yield of the asset. So some considerations on an RCC roof. Obviously, we'll have to look at the shadow-free area. RCC roofs are usually come with a lift building, a lift room that is on the roof, or there will be parapet walls that provide some shadows into the usable area. So we have to take those into consideration. We have to also understand what is the roof plan for the future. Many RCC buildings have pedestals, not pedestals. They're these concrete blocks that are placed for elevation of another floor. So that ties up into what kind of structures we will use. Will it be fixed structures or movable structures that they can take to the next floor? And shadow analysis of all obstructions is done on. There are a couple of softwares to do this. We use Google SketchUp. So other considerations that are taken are the weather, whether the structures can be grouted to the roof. If they are, let's say, ceramic roofs, clients do not prefer chipping of the roof. So we will have to come up with alternative solution. We use weighted ballasts in those cases. Layout orientation. In an RCC roof, we have more freedom to move the panels and orient them true south, but sometimes this might change the total capacity of your solar plant. So we have to do a cost benefit kind of takeaway on which would improve the client's savings. And usually load is not an issue in an RCC roof because they're built to take much stronger loads than a typical sheet roof. So as you can see here, this installation uses ballasts, so it doesn't require surface chipping. This particular client wanted to have the freedom to elevate his floor, so the panels are placed very close to the ground. While this gives him some benefit in terms of his future plans for the facility, it will definitely reduce the solar yield by a small amount as compared to if we would design a structure, a permanent structure that optimizes the generation. So once we have finalized the solar capacity based on space, all considerations are taken into account. We create a layout on an AutoCAD software, and this is plugged into our proposal. which is given to the client after our economic analysis. So before going into the economics of the plant, I'd like to talk a little bit about the factors that should be considered in a BIPV system. Sonia has already mentioned some of this, but let me go through it briefly. The requirement for the light in the building is a huge deciding factor on which type of BIPV modules that need to be used. There are a couple in the market, so the more amount of light and visual capabilities that we have to provide in the glass, the lesser will be the efficiency of the module. So BIPV modules are typically glass modules. So the front face and back face will be glass, and PV cells are integrated in the middle. If we want larger quantum of light to pass through, a larger amount of light to pass through, then the cells are spaced further apart. So the overall capacity of the particular module will obviously reduce. Thereby, its efficiency will reduce. However, if the PV modules are placed closer together, the efficiency will increase, but the amount of light that will pass through will reduce. So we have BIPV modules starting all the way down to 150 watt peak, going all the way up to 600 kilowatt peak, 600 watt peak. And the transparency of the module moves from 120, which is the highest, to opaque, which is 600. The dimension of the facade is also important, specifically in curtain walls and facade-based systems. So curtain walls use the BIPV as a curtain. They diffuse the light. The glass needs to diffuse the light before entering the building, while facade systems can be completely opaque. But both of these use aluminum frames. So these frames need to be designed to the dimensions of the modules, which typically is manufactured at 2x1. If we try to customize these, then the costs increase. It is possible, but the manufacturer will charge greater for those type of modules. The shadows falling on the building also will have to be considered. Shadows falling on buildings typically are not moving shadows. They stay fixed through the year. So at most, the size of the shadow will vary. So we have to ensure that we work with the architect to select the area of the building that does not have a lot of shadows. And the selection of material and equipment is also important to assess the efficiency of the plant over time. BIPV plant needs to be designed and executed very well at the early stage because it's complicated to run regular maintenance, unlike a rooftop plant. It's more expensive to get cranes involved for you to send an engineer on the outside of a facade. So we try to select equipment that have built-in mechanisms such as optimizers or breakers and things like that can give us an understanding very specifically of what an issue is, and then we can take a call on whether an investment has to be made to improve on that. There's only really one crucial question if somebody wants to explore a BIPV plant, and that is the building a greenfield project? It is not commercially viable to retrofit BIPV. In fact, it's not BIPV if you retrofit it. It needs to be integrated into the architecture of the building. So if it is a greenfield project, then we will start working with architectural firms, facade consultants, and an EPC company such as us that can curate a solution, curate a building that satisfies every single requirement. The architect creates an aesthetically pleasing, realistically constructed building. The facade consultants will come in and provide their services on the material type, and we will offer our solutions on the electrical capabilities, the integration, the requirements for how what panels will be installed, how will the wires be run across, what will be the capacity of the solar plant, what would be their savings, so on and so forth. This creates a BIPV system that is actually market deployable. So coming to this, we do offer BIPV consulting services. So we work on the feasibility of the architecture drawing. It is a stakeholder interaction, multi-stakeholder interaction. So we work along with the architects. And on the other side, we also work with the facade consultants. We do an entire technical evaluation of the, some of the steps are very similar in the energy portion of it. But BIPV is complex in the fashion that the modules that we use are quite different. There are no standards that we can follow, and each building is its own unique thumbprint. So we have to benchmark the modules based on the requirement of that building, the requirement of the energy that needs to be generated, and the requirement of the design. So once this is done, we offer a couple of options to our end customer, typically real estate developers, and we also provide them analysis on generation and shadow. We provide them with the solar module layout. We also provide them with other drawings, what the SLDs will look like, and work along with the facade consultants to ensure that the facade has the structural stability. Then we will run a commercial modeling on these different options and present the findings to the client. I'd like to explore the economics of solar adoption. The first thing that we need to understand is solar or any other renewable energy source for that matter has the similar perspective on the economics. The savings that the renewable energy source needs to provide needs to be formulated by having a low levelized cost of energy, LCOE. So levelized cost of energy is calculated by total lifetime cost. This includes the investment and expenditures. So the first capital cost for installing the solar plant plus the lifetime maintenance cost. Then your fuel expenditures for the year. FT in this equation would be 0 because once a solar plant is installed, there's no more fuel expenditure. Then that is divided by the discounted rate, which would be the degradation factor of a solar module, typically 0.7% per year, and the expected lifetime of the power system, which is N. For solar, the nameplate lifetime of a plant is 25 years, but if maintained well, they can go up to 30 years. So yeah, I'm not going to get into the details of the formula, but here it is. It's pretty simple once you understand what LCOE is, and you get a savings on solar, a return on investment in solar when your savings equals your capital investment. So for a rooftop solar, this typically happens within 4 to 5 years because your capital investment is around 4.5 CR. Ground-mounted solar within the premises. Within the premises means that it's inside the factory facility or inside the mall. If it is outside of a private space, it is called open access, which is a completely different thing. We are only talking about distributed energy today. So for a ground-mounted solar, it's about 4.5. This is because ground-mounted solar systems can generate higher energy, but we'll have to invest slightly higher capital. So the yield where it is 1350 to 1400 on a rooftop plant can be greater than 1600, even 1800 in some cases for a ground-mounted project. BIPV systems, the ROI needs to be looked at from the perspective of replacing a material. I cannot, emphasize that enough. So the investment and expenditures, which is I in this equation, needs to be reduced by the capital cost of the solar installation. So we will subtract the cost of the amount of glass that would have been used or the aluminum frame that would have been used, so on and so forth. So there is a slight change in this equation. In that case, we subtract the material. So thereby the ROI is still very similar because you're replacing something that would have only one utility with something that has both. So not only with your solar glass create insulation, but it will also generate energy. A solar carport system has high capital investment because it uses superstructures. These are expensive to design and also expensive to install. But you still get an ROI of 5 to 6 years. For facilities that use huge quantum of energy, don't have enough rooftop space but huge car parking space, this is a very viable solution. To summarize, the selection of technology depends on space availability. If it's a BIPV system, then we use a multi-stakeholder approach, and we offer solar consultancy at early stage for greenfield projects. Solar is a no-brainer. As you understand, for a 25-year lifetime, you receive an ROI within 4, max 6 years. So that's pretty much over 20 years of free energy. So it is definitely a no-brainer. Everybody should do it. Distributed energy should be your first step in your energy transition process. It also creates, more sustainable outlook in design. So yeah, I hope I've convinced you as promised. So RE integration. While we have spoken in detail about solar, other energy sources will follow similar process. First, you have to study the energy patterns, then you select the technology based on the sizing of the system, and you have to evaluate the policy compliances. These 3 things go hand in hand. Yeah, I would still say solar is the best distributed renewable energy because specifically being located in the Indian subcontinent, if your facility has space, you should install solar there and then explore other, RE sources to complement it. A hybrid renewable energy system is obviously best. That will maximize your clean energy utilization. Larger corporates today have options to finance their solar plants via the OPEX model. Where PPAs are signed between 20 to 25 years. So this essentially means that at no cost you can adopt a solar plant. So you have absolutely no hassle. The plant is maintained by the developer and you provide great savings. Yeah. Thank you. I'm open to questions if there are any.
Thank you, Dhwani. We can take some questions now. If there are any questions, please post it into the questions tab. Meanwhile, I'll check if there are any questions. So we have got a couple of questions. I'll take them. I'll just display them on the screen. There's a question from Mr. Deepak. Generally, 60% of building energy electricity consumption is in HVAC. Is there any early technology available for HVAC? I think yes, we can have a couple of technology options for the HVAC also. We can basically supplement the renewable energy for HVAC system. Specifically, biomethanation system can be used for powering vapor absorption chillers, and also geothermal heat pumps can be used for powering the space heating using some of the renewable energy technology as an input, and utilizing the geothermal heat. So there are a couple of technology available for this as well. So there's another question from Mr. Jotham. What are the other options for RE except solar and wind? I think Sonia covered that. Sonia, do you have any other point on that?
No. So we already covered that. Apart from solar and wind, we have biomass as a very viably available natural resource which can be utilized. Specifically, if you're talking about buildings, so these are the three main resources which are available. Then fuel cells is another option which is in development and probably would be a good option once it is commercially available and viable.
All right. Then we have a couple of questions from Mr. Joy. What is about breakability of the glass for solar panel on wall? What is the safety consideration? And what is the range of RE produced per square meter of land area? Dhwani, can you answer these questions?
Sure. So, Mr. Joy, the breakability of glass on solar panel on wall, pretty much the same quality considerations are taken in when designing a BIPV module as that you would normally put on, a wall. So Windows BIPV panels that are designed for Windows have the same quality and safety metrics. Thickness is one thing that we have to look into, and yeah, they are tests that they do before deploying these products to market. So any manufacturer should be able to provide you safety certifications. Sorry, your next question was on the range of RE produced per square meter of land area. Typically, it's I would say we use 4 acres for 1 megawatt, and 1 megawatt will be able to generate minimum 1500 units per year. So, sorry, 1.5 lakh units per year. If the plant is optimized with trackers true south, using good design methodologies, it can go up to 1.8 lakh units per year as well.
Thank you, Dhwani. The last question is from Mr. Intukab. It's about the efficiency of hybrid solar PV panels. So these panels are relatively new technologies, and since they generate both electricity and the hot water, they have slightly higher efficiencies, either the singular technology of solar thermal and PV. The efficiency claimed by some of the manufacturer is in the range of 30 to 40%. And you can see the details in the handout section. We have shared the technology tip sheet with you. You can download and see the details of each of the technology and what are the products and what are the efficiencies. It has been mentioned in that. So with this, if there are no further questions, we can, this brings us to an end of the webinar, first webinar of the series. Thank you very much for joining us, and hope this is going to be a useful series for all of us, and we'll be learning about all the technologies and how we are going to utilize them in our building projects, how we are going to be using the integration of renewable energy in buildings using all these technologies. So I hope that is going to be a very interesting discussion further also, when we will deep dive into the individual technologies and we'll see how each technology is performing, how each technology is selected and designed in detail in the upcoming session. So hope you will join us for the next all the webinars. The next webinar will be on 3rd of the March, and that will be into we'll be deep diving into the solar PV systems on the rooftop, ground mounted, and all other options which are available, how we design and how we execute a project from end to end. So with that, I thank you all. And with this, we come